When I see people talk about the applications of quantum computing, they go into domains where the problems are so complex that they are very difficult, if not virtually impossible, for existing or even foreseeable conventional computers to actually resolve them. So the NQCC is there to help with the challenge of scaling quantum computing. A big issue in quantum computing has been taking it from having what we call qubits, these small numbers of qubits, towards the ultimate aim of having systems which have many, many qubits, but scaling also the application of quantum computing, helping develop the software that goes with that to enable that to happen, and also the potential user community for quantum computing as well, scaling that community too.
The NQCC is the National Quantum Computing Centre. It's the UK's national lab for quantum computing. So the idea of the NQCC is to act as a kind of focal point for both the research, the business side, usage and applications of quantum computing, which is this new emerging technology.
The aim of the NQCC is to operate at a technology readiness level where we are bridging the gap between fundamental research and product development. So in terms of research, like hardware research, I think then we can have our internal research teams exploring things which would help. One thing is that the NQCC can shape and direct the efforts. If you think of different groups, this was already happening with the quantum hubs. When you have a coordinating institution, you can integrate people better, and then this speeds up the development, because if you think people are not isolated anymore, if they're looking for the same solutions or the solutions for the same problems, they can communicate, they can work together, and they can speed up change.
So I think you can see NQCC being another part of the ecosystem. So NQCC should interact with the academic research base in terms of them flowing through the outputs of their research into what you might call the next stages of development of the technology. NQCC will have its own, what you might call, technology program, okay? And that will have different facets. That will have facets which are the interactions it has with academia, and some of that might be even involved in joint projects. So there could be projects in academia led by academics, which NQCC is a partner on. That could even include them commissioning research activities to happen as well. That could go to different levels where you have things like the testbed program. Okay, those are testbeds that are actually developed by industry, often hosted within the NQCC, and they're early stage systems that it allows them to show what they can do, to demonstrate what they can do. But there's a big advantage of the NQCC having multiple testbeds, these early stage platforms. They're not what you might call fully operating quantum computers. People aren't really at that stage. They have early stage systems that can show promise. A real computer has many different elements and systems within it. It has memory, it has processing, it has communications, it has interfaces. These test beds are things which allows you to actually see what they can do and actually then understand what needs to be done next to progress the technology.
The main technologies that we are working on in the NQCC is superconducting qubits, trapped ion qubits and neutral atom qubits, also photonic systems and spin qubit system. So we're actually covering quite a breadth of quantum computing technologies just within the UK's national lab.